Welcome to Servosoft, the optimal solution. This tutorial showcases Servosoft's powerful curve fitting feature, finding the optimal ramp against one or more rated limits. Curve fitting is part of the Optimizer Pro option. Use curve fitting to build an acceleration or deceleration ramp or a complete move that is as fast as possible within rated limits and margins that you specify. Curve fitting is a perfect example of Servosoft doing what no human can do, creating a perfectly optimized move in a matter of seconds. Let's begin. Here is a project with the mechanism and sequence data and the infeed, drive, motor, and gearbox already selected. This is a single-axis inverter on a shared bus with an infeed regen module to feed and regen the bus power. This conveyor-driven pick-and-place application's primary objective is to get from A to B as fast as possible. As shown by the utilization bars on the main form, the existing sequence is limited by the infeed and drive, each operating at 90% utilization or a 10% margin. Now, let's look at the sequence form. Let's see what profiles we have in the sequence chart. We have the load velocity, load accel, motor torque, drive inverter current, and infeed bus power. You can see where the limits are for the infeed peak power and the inverter peak current. The sequence is simple, just one move followed by a dwell. There are thrust steps of 1200, 1500, and 1200 newtons for accel, constant velocity, and decel. The second move is just a copy of the first move. The second move will be curve fitted. I will rename the move curve fit. Note, the move time is 762 milliseconds with a distance of 2 meters, and the jerk is only 130 and 300 meters per second cubed for accel and decel. This is done to help shape the move under the drive curves. This is best seen in the motor torque chart, which I will display now. You can see the accel is limited by the infeed peak power, and the decel is limited by the inverter's peak current. As this chart shows, the motion profile is about the best that can be achieved with a traditional S-curved motion profile. It is important to note that the actual mechanism can handle a jerk of 350 meters per second cubed, but we just can't use it here because of the mentioned infeed peak power and inverter peak current limitations. I will select the move, then right-click and select Curve Fit Spline. Since I have selected a move, the curve fit form is showing all the parameters to curve fit a move. If a segment had been selected, then the move-specific parameters would be hidden. Note that the profile type is Poly 1-7, which is not supported by all controllers. So another option is Poly 1-5, which typically results in a few more segments in the final spline profile. For this example, I will stay with Poly 1-7. To start the process, I will click OK. The curve fit algorithm works away for 2 minutes, and then when done, a summary analysis appears showing the before, after, and changes. In this case, we have gone from 762 milliseconds to 697 milliseconds, which is 65.7 milliseconds or 8.6% faster. And the number of segments have increased from 3 to 30. The sequence from underneath is also updated with the curve-fitted profiles. I can click Save to accept the results or Cancel to revert to the original move. I will click Save. Let's take a closer look by zooming in on the curve-fitted move. It is clear how the limits and margins are maintained for jerk, in-feed peak power, and inverter peak current. The sequence form is a good view. However, the best place to see this is the drive and motor performance chart. I will select and highlight just the curve fit move, which is named here as segments 2 to 31 spline. And now I will display the drive and in-feed rated curves. See how the accel and decel ramps bump up against the inverter rated peak current and in-feed rated peak power curves for both the accel and decel ramps? We now have the optimal move profile against those rated curves with 10% margin as specified. We can take this a step further. In this application, the in-feed peak power is a major limitation for increasing the max velocity when using an S-curve profile, but with curve fitting, we can do so. Why not increase velocity by another 10% from 4.78 to 5.25 meters per second? Let's see what happens. This time, the move time is reduced to 684 milliseconds, which is 78 milliseconds or 10% faster than the original S-curve move. And with 10% margin or better on all components, we can run this system in the real world. This is not a theoretical solution. You can take this to the plant floor. What if we have a dynamic load that is changing as a function of velocity? Let's start again, but this time specify a thrust formula. First, let's enable the load thrust profile. Now you can see the thrust steps in the first profile in the chart. Now I will enter this thrust formula. Note that the max thrust is 1500 newtons, just as it is in the original move. Now you can see the oscillations in the thrust profile due to our thrust formula. Now let's curve fit this move. Because of the dynamic thrust load, I'll increase the accuracy to better, which quadruples the resolution. This time it took a lot longer because of the higher resolution and the load formula that must be calculated with each iteration. Once again, the motor torque, inverter current, and in-feed bus power profiles bump up against the rated profiles even though the thrust load is oscillating. Once again, looking at the motor and drive performance chart, curve fitting has smoothed out the thrust load oscillations, maintaining 10% margins for the inverter peak current and in-feed peak power. Curve fitting finds the optimal ramp no matter the load. No guessing, no more, it's good enough. Now, with a click and within seconds, you get the optimal profile. If you compete on performance, then curve fitting is a must. This tutorial has shown just a few examples of what the curve fitting feature can do. Curve fitting is part of the Optimizer Pro option. please contact us so we can show you how the ServoSoft Optimizer and curve fitting can improve your designs. This concludes the ServoSoft tutorial on curve fitting. Thanks for watching.